The history of math is our intellectual foundation for understanding science. Science. Beautiful, awesome, wonderful science. It's the creative foundation for our ineffable future. Hi, I'm Gabrielle Burchak, and this is my podcast, Math, Science, History. And now a quick word from a podcast that I think you might like.
Hi there, I'm Leah.
And I'm Steve, and we're the hosts of a podcast called Remnant Stew.
We release an episode every other week that features weird, bizarre, and intriguing true stories.
That's right, we track down and bring to you some of the weirdest stories and trivia, like the shrimp that spits up a glowing loogie, or the turtle that survived being locked up in a room and forgotten for 30 years.
Or that time a shark on display in an aquarium puked up a human arm that sparked off a murder investigation remains unsolved to this day.
I love that story.
So if you need a break from the news and want something to satisfy a curious mind, then tune in to Remnant Stew. We're available on Spotify, Apple Music, Google Podcast, or any of your favorite podcast platforms.
We hope you'll tune in and join the adventure. And in the meantime, as always, please remember to be kind and always stay curious.
In my last show, I note that in 1494, Fra Luca Pacioli published his book Summa de Arithmetica Geometria Proportione, which is commonly referred to as the Summa. In the conclusion of his book, Pacioli stated that the solution of a certain cubic equation was as impossible as squaring the circle. In other words, he was saying that this is an impossible problem. This equation begins the second part of my story about the competitive and diabolical world of math. Pacioli passed away in Brescia in 1517. 1 year prior, in 1507, a new mathematician, 20 years younger than Pacioli, entered the scene of academia. This mathematician was Scipio del Ferro. Del Ferro was born on February 6, 1465. In 1496, he was appointed as a lecturer of arithmetic and geometry at the University of Bologna. He was a brilliant man, and it's unfortunate that we're not able to see his works because he kept them hidden. At the time that he lived, the mathematics community was very competitive because there was money to be made at these math competitions. The academic climate was so competitive that people held their solutions close to their chest, kept them secret, and rarely shared it with others. The only reason why we know about Del Ferro's mathematical works is because he kept his work in a secret notebook. On his deathbed in 1526, he gave this notebook to his son-in-law, Hannibal Nave, who was also a mathematician. Conveniently, his son-in-law was able to take over Del Ferro's position at the university, and in an interesting turn of events, he also took the name Del Ferro. However, Nave was not the only mathematician in Del Ferro's circle to have witnessed and seen his mathematics. Del Ferro also taught a student by the name of Antonio Maria Fiore, whom he considered to be a trusted student. As a result, as Del Ferro was dying, he also shared his mathematics with Fiore. Apparently, he had a lot of visitors while on his deathbed. Considering that the mathematical community at this time was extremely competitive, Del Ferro's work remained hidden from the public. Possibly, Nave and Fiore hid their knowledge of Del Ferro's work from each other, and rightly so. They each had a secret that was worth a lot of money. You see, when Del Ferro worked at the University of Bologna in 1501, he met Luca Pacioli when Pacioli arrived in Bologna to teach at the university. They became friendly associates and often discussed their work with each other. When Pacioli discussed the infamous cubic equation that he published in 1497, as well as the lack of an algebraic solution, Del Ferro was inspired to prove this equation algebraically. During Del Ferro's time, it was already known that the general cubic equation could be reduced to x cubed plus ax equals b and x cubed plus b equals ax, but it could not be reduced to x cubed equals ax plus b. However, these solutions only involved positive numbers. 0 was not applied to the solution, and it was not known that the quadratic of this equation could have 2 roots through the quadratic formula. To this day, we still do not fully know how Del Ferro solved this equation. Furthermore, at this time, nobody knew that Del Ferro had solved it because the solution was being kept a secret. Meanwhile, about 180 kilometers north of Bologna, in the city of Brescia, there lived a mathematician by the name of Niccolò Fontana. He was born around 1499 to Michele Fontana. His father was also known as Micheletto the Writer because he delivered mail to other towns around Brescia. And sadly, and for reasons unknown, his father was murdered while delivering mail when Niccolò was only 6 years old. In 1511, the northern part of Italy was in a precarious position. France's King Louis XII was the Duke of Milan. Pope Julius II was aware that France's wealth over Milan could take over the entire Italian peninsula, which could overthrow the papacy. And so, Pope Julius began to form anti-French alliances. He aligned the papacy with England, Rome, Spain, Venice, and the Swiss Confederation. The Pope's goal was to drive out the French. And on October 5th, 1511, the papacy formed the Holy League, which was a large group of military forces. By February 1512, the Battle of Ravenna was underway. France and the papacy were at war. Unfortunately, Italy and the citizens of Brescia would be the ones to suffer the most. On April 11, 1512, the French military commander Gaston de Foix instructed his forces to enter Italy. In the beginning, the Holy League forces in Brescia managed to push back the French military. However, the French military was embarrassed by this defeat and decided to carry out retribution. As a result, they entered Brescia and murdered tens of thousands of innocent residents of this great Italian city. The innocent citizens of Brescia had been decimated by French troops and bodies were everywhere. It was a tumultuous time as people were pulled from their homes and murdered. And so, Niccolò and his little sister and his mother ran and hid in a church. Unfortunately, the French soldiers found them. Determined to kill Niccolò and his family, one soldier sliced the 12-year-old's jaw and palate with a saber. After the soldiers left the church, his mother looked for him and found him bleeding profusely. If she hadn't found him when she did, he would have bled to death. Niccolò's face had been mutilated so much that he had a permanent scar across his face and struggled with stammering. Or, as referenced in Italian, he struggled with tartagliare. Thus, Niccolò had taken on the name Tartaglia, which is why we now refer to him as Niccolò Tartaglia. As he grew older, he grew a beard to cover his scars. And now a brief message from today's sponsor. Everybody wants more energy. Even when you exercise and take care of your body, sometimes that energy still isn't there. If you can relate, consider Athletic Greens. Whether you eat keto, paleo, vegan, dairy-free, or gluten-free foods, Athletic Greens, also known as AG1, is a product that you can drink every day. It helps give you more energy, helps with your gut health, and it optimizes your immune system. AG1 gives you 75 high-quality vitamins, minerals, probiotics, and adaptogens. For less than $3 a day, you can reclaim your health. What I really like about AG1 is that for every purchase, they donate to organizations to help feed kids in need. Also, Athletic Greens will send you a free 1-year supply of immune-supporting vitamin D and 5 free travel packs with your first purchase. Just visit athleticgreens.com/emerging. That is EMERGING. Again, that is athleticgreens.com/emerging to take ownership over your health and obtain the ultimate daily nutrition insurance. Growing up, he didn't receive much education because the family income solely relied on his mother. She had saved up just a little bit of money in order to afford a writing tutor for Tartaglia. However, according to Tartaglia, by the time he had learned about the letter K, the money had run out. But this didn't stop him. He purloined his master's notes and taught himself, completing the course through his own efforts. According to the historian Richard Feldman, he was resourceful. Thus, when he needed writing slates, he wrote upon tombstones to practice his mathematics. The only area where his education fell short was learning Latin, which at the time would have seemed to be a hindrance to his mathematical career. However, having the only option but to write his treatises in Italian served the Italian mathematical community and his career quite well. As a result, the Italian mathematical community would eventually benefit from his translations of Archimedes and Euclid. As a young man, he was a very skilled mathematician. His mother recognized this and found Tartaglia a patron by the name of Ludovico Balbisonio. Tartaglia and Balbisonio traveled to Padua, where he would learn mathematics. And when he returned to Brescia with his patron, proud and filled with egotistical hubris, well, this inflated ego didn't do well for his popularity in Brescia. And so he moved to Verona, where he taught between 1516 and 1518 at Palazzo Mezzanti. His earnings were meager, even though he had a sustainable income as an arithmetic teacher, which at that time was referred to as an abacus master. Much like Luca Pacioli, he traveled as a teacher. While Tartaglia was living in Verona, he had been contacted by a Brescian professor by the name of Zuan di Tonini da Coi. Da Coi had presented Tartaglia with two algebraic cubic equations. Tartaglia was intrigued and set out to solve them. These equations were of the form x cubed plus 3x squared equals 5y and x cubed plus 6x squared plus 8x equals 1000. They were tricky. People were trying to solve these cubic equations algebraically. Meanwhile, he needed to make more money for his family, so at the age of 34 in 1534, he settled in Venice, Italy. At the time, he was an unknown. However, he began to earn himself a credible reputation by taking part in debates and mathematical duels. Tartaglia had become something of an expert in Archimedean physics. He worked with the engineers and soldiers of the Venetian arsenal. They had consulted him as to what angle a gun should be at to make it shoot the farthest. His answer, as basic physics teaches us, is at a 45-degree angle. He had made this determination through an empirical observation, and even though the soldiers didn't believe him, they tried it out and learned that Tartaglia was correct. While in Venice, he published two books that were sequels. The first one, La Nuova Scientia, which means The New Science of Artillery, was published in 1537. The second book, Quesiti et Inventioni Diverse, which means Problems and Various Inventions, was published in 1546. And as a reference to his empirical observations, he prefaced his second book with a promise that the mathematics are based on, quote, new inventions not stolen from Plato, from Plotinus, or from any other Greek or Roman, but obtained only by art, measurement, and reasoning, unquote. What is interesting about these two books is that he wrote them in the form of a dialogue. It was this unique form of writing that Galileo also utilized 100 years later. So again, Tartaglia was resourceful. His books and his teachings had begun to earn him money. However, a portion of his income also relied on some mathematical duels. Often, the winner of these mathematical duels would not only earn credibility, but also an academic position within the university. Meanwhile, there were rumblings that there was one person from Bologna who could solve cubic equations. This intrigued the mathematical community, and this one person was Antonio Fiore, the individual who obtained the secret equations from his teacher, Scipio del Ferro. Tartaglia, who had been working on these same cubic equations, was intrigued. So, when Fiore challenged Tartaglia to a mathematical duel in 1535, Tartaglia accepted. The difference between the two was that Fiore was confident that he could win because he obtained the secret solutions. Tartaglia, however, was confident that he could win because he had been working on these equations for the last several years. So, who do you think won? Well, the competitions were set out as follows. The two competing members would present the other with 30 questions. Fiore submitted his 30 questions to Tartaglia, and Tartaglia submitted his 30 questions to Fiore. Knowing a little something about cubic equations, Fiore expected to receive equations that were similar to the one that Del Ferro had shared with him. However, Tartaglia, who had been working on these equations, submitted many equations that were unfamiliar to Fiore. After receiving their equations, they each went their separate way. Tartaglia was confident that Fiore would lose simply based on Fra Luca Pacioli's statement about the difficulty of his cubic equations. Tartaglia wrote that he, quote, thought that not a single one could be solved because Fra Luca Pacioli assures us of their difficulty that such an equation cannot be solved by a general formula, unquote. So he was confident that Fiore would lose. They each had 50 days to complete the equations and submit them to a notary for verification. But after 41 days passed, Tartaglia heard gossip that Fiore had a secret that was aiding him in solving the cubic equation x cubed plus ax equals b. This roused panic within Tartaglia, who now realized that Pacioli might be wrong. And so, early the next morning, 8 days before the deadline, Tartaglia sat down and within 2 hours solved all of Fiore's problems, including the additional cubic equation x cubed equals ax plus b. Meanwhile, Fiore was still confused with Tartaglia's equations. He could not solve any of them using Del Ferro's previously used methods. Tartaglia had won the mathematical duel. However, Tartaglia was a man of principle and didn't want to take the prize. He believed that the true reward simply came from winning the competition. As a result, Tartaglia was a superstar on the mathematical scene. He wrote that he knew and understood how to solve these cubic equations that included, quote, squares and cubes equal to numbers, unquote. Tartaglia had established himself as a credible mathematician in Venice and the winner of the infamous Tartaglia-Fiore duel. Many wanted to know Tartaglia's secret, but like Del Ferro, he held the answer close to his chest. His intentions were that nobody would ever learn this secret, but someone would, and it would be in the most malicious, diabolical, sneaky way. Stay tuned for my next show when I reveal who won what, who worked with who bribed who, and who threw who under the bus. So much math and so many secrets. Who knew that math could be this diabolical and fun? Until next time, carpe diem. Thank you for listening to Math, Science, History. If you enjoyed this, please remember to leave a review. I would really appreciate that. If you're interested in the transcripts, you can visit me at mathsciencehistory.com. If you're interested in watching the show on YouTube, you can just search for Math Science History with Gabrielle Burchak. And finally, if you're interested in supporting Math Science History, you can donate through my website's coffee button, or you can visit Patreon at patreon.com/mathsciencehistory. All tiers are now pay what you want, starting at $1.39, because 139 is a happy number, which means that when you sum the square of each digit, it eventually reaches the value of 1. Until next time, carpe diem.